Hi everyone, we are back with another paper of JEE Mains 2024. Now we will be discussing the chemistry section of 29th January shift 1 paper. Again the paper was very simple. The questions of inorganic chemistry were directly from the NCERT. First we will be discussing the questions from inorganic chemistry, then physical chemistry and then organic chemistry. Okay, so let's get started. The first question is which of the following will be formed on decomposition of KMnO4, and there were few options. So if we talk about KMnO4 is permanganate. On heating or on decomposition, permanganate gives us manganate, MnO2, and oxide of manganese and oxygen gas. This is the pattern of decomposition. It is a probable question that we can have which of the following will be formed on decomposition of K2Cr2O7. They may ask this question again because lot of questions are being asked from DNF block. So we get on the reactant side we have dichromate. From dichromate we can have chromate and Cr2O3, which is an oxide of chromium and oxygen gas. Right? Next question is from coordination compounds. They are asking which of the following has bridging carbonyl ligand. So let us make the structure. The first compound is Mn2CO10. So if we talk about each Mn is connected to 5 carbonyl groups. So the structure is something like this. There is no bridging ligand. If we talk about CO2-CO8, the structure is like this. We have CO ligands connected on the bridge. Okay. These are cobalt atoms and others are the ligands. These all are ligands. So this is the structure of CO2-CO8. We have CO as a bridging ligand in this case. C and D, we cannot have any bridging ligand. Why? Because there is only one chromium present, right? So in the case of one metal ion, we can never have a bridging carbonyl ligand. So I can rule out D as well. Right? This question has been asked before as well. Next is again a direct question from D block. Alkaline KMnO4 oxidizes iodine to a particular product A. Determine the oxidation state of iodine. So if we talk about KMnO4 in alkaline medium, or I can say slightly alkaline or neutral medium. So basically we generally get MnO2 and iodine is oxidized to IO3-. This is the case in slightly alkaline or neutral medium. Because if it was highly alkaline, we would have gotten MnO4 2-, which is manganate ion. So again, a question can be asked if we had KMnO4 in acidic medium, another product would have been different. We get iodine gas if it was acidic medium. Okay, so in alkaline or slightly alkaline medium we get IO3-. In acidic medium we get I2, iodine gas. Next, electronegativity of group 14 elements decreases from silicon to lead. So if we talk about the group 14 element, it is carbon, silicon, germanium, tin and lead. If we talk about carbon, or if we talk about the complete group, as we go down, generally the trend is electronegativity decreases. But if we talk about silicon to germanium transition, in this case the electronegativity is slightly increasing because just before germanium we have D block elements, and due to poor shielding of D orbitals, that effective increases and slightly the electronegativity is increasing. So there is an irregular trend as we go down in group 14. So the first option is incorrect. If we talk about the second statement, so we know carbon is non-metal. If we talk about silicon and germanium, they are metalloids. And finally, tin and lead are considered metals. So the second statement is correct. Right? Moving on to the next question. How many of the following compounds have one lone pair on central atom? So a question directly from chemical bonding, hybridization part. I hope all of you know how to calculate hybridization and do not use a complicated way to determine hybridization. There are various formulas, but I'll tell you the simplest formula is to calculate the total number of valence electron and divide it by 8. If it is perfectly divisible by 8, that is our steric number. If it is not divisible by 8, whatever the remainder is, divide the remainder by 2, you will get the steric number. Right? I'll give you an example. Let us talk about ClF3. So there are 7 valence electron in chlorine as well as fluorine. So I'll write 4 into 7. These are total valence electron. So out of 28, I can write this as 24 and 4. 28 is divisible by 8. 24 is divisible by 8. So I'll get 3, and from the remainder which I'm dividing by 2, I'll get 2. So basically, whenever we divide by 8, we get the number of bond pairs, and whenever we divide by 2, we get the number of lone pairs. So we have 3 bond pairs and 2 lone pairs. So this is not our answer. If we talk about XeO3, xenon is 8, oxygen is 6 into 3, which is 18, and 8 is 26. 26 is 24 and 4. Sorry, 24 and 2. So I'll get 3 bond pair, 1 lone pair. Right? So this is correct. BRF5, 7 into 6 is 42. 42 is 40 plus 2. So 40 by 8 and 2 by 2. 5 bond pair and 1 lone pair. If you do not believe me, you can draw the structure and you will find the same thing. So this is also correct. XeF4 is 8 plus 4 into 7, which is 28 and 8, 36. 36 is basically 32 and 4. So as you can see, we are getting 4 bond pair, 2 lone pair. So that is not our answer. NH3 and O3, I think you can directly make the structure instead of determining the hybridization. There is 1 lone pair, and if you talk about O3, it is like this. Right? So both of these have 1 lone pair. However, you can calculate the hybridization of these two as well in the similar fashion. And now one thing I would like to add here is always take the number of electrons for hydrogen as 7 while using this method. Okay, you will get the correct answer. So the correct answer for this question is 4. Next question. So we have seen in every shift a question from molecular orbital theory is being asked, right? Let us talk about helium 2 plus 2. Helium has 2 electrons. He2 will have 4 electrons, but we have removed 2 electrons, so it is basically a 2 electron species, which is just like H2, and H2 is sigma 1s2, right? So this is diamagnetic species. So this is not our answer. O2 2 minus. Oxygen has 6 valence electrons, or if you want to calculate the total number of electrons, it is 8. 8 into 2 is 16 plus 2, because 2 minus means extra 2 electrons, so total 18 electrons. So it is just like F2, and F2 is having a bond order of 1, which is correct, and it is diamagnetic, right? F2 is diamagnetic. So I think this also goes away. Let us talk about Ne2 2 plus. If we talk about neon, neon is having 10 electrons. 10 into 2 20, and 2 plus means we have to remove 2 electrons. Again, it is isoelectronic to F2. This is also not, this is also incorrect, right? This is also diamagnetic. If we talk about B2, B2 is special. Sigma 1s2, sigma 1s star 2, sigma 2s2, sigma 2s star 2. In this case, mixing takes place, so we will get pi 2px1 and pi 2py1. So you can see bond order would be 1, 1. Bond order is basically the number of bonding electrons minus anti-bonding electrons by 2. So bond order is 1, and as you can see, each orbital has 1 electron, so it is paramagnetic. B2 is our answer. H2 is not our answer, as discussed here. O2 2 plus. So O2 has 8 electrons, again 16. 16 minus 2 would be 14 electrons. So 14 electrons is N2. And if we talk about N2, N2 is diamagnetic, it has bond order of 3. So there is only one correct answer. Right? Take special care of molecular orbital theory. A question is definitely going to come in your shift as well. Now you might be wondering that from which chapter we have gotten this question. This is actually taught majorly in metallurgy, but you can find all of these compounds in P block. Okay, when you read the NCERT, you will find this, I think, on the first or second page itself. Right? But if we talk about, I think C, you already know. We studied this in class 9th or 10th. Bauxite is basically an ore of aluminium. So that should be matched with Al2O3. Dolomite, as you see, it says Do. There are two salts here, MgCO3 dot CaCO3. Fluorspar, if you would have taken a guess, I think it is CF2, and cryolite is Na3LF6. These are extensively used in metallurgy, but yeah, these are present in P block elements, NCERT as well. So I would say this was an eye-opener for the students who have exam in the coming shifts, that you can go, you should remember some of the compounds from the NCERT directly, although they are not being used. Okay. Ziegler-Natta catalyst was present in 27 shift 1 or shift 2 paper as well. Ziegler-Natta catalyst is basically TiCl4 and AlC2H5 whole thrice. So if we talk about this, it is, we are unsure whether titanium was present or aluminium was present or both of them were present. So anyways, I can match this with titanium or aluminium. Blood has iron. Every kid knows this. Wilkinson catalyst is rhodium, RHCl PPH3, triphenyl phosphine. Okay, so it is to be matched with rhodium. Vitamin B12 has cobalt in it. Next, which of the following elements is or are confirmed by the presence of blood red coloration with FeCl3? I think this is a very simple question. If you know, if we have ferric chloride, we can have FeSCN 2 plus, or you can also say we can have FeSCN3, which is blood red coloration. Now this is very important. This has been asked multiple times in multiple exams. Right? This is blood red coloration of thiocyanate ion. This test is of thiocyanate ion. If we have sodium, we have soda extract anyways. Then if we have sulfur, carbon and nitrogen, if it is an organic compound, we already have carbon. If we have extra sulfur and nitrogen, we will get NaSCN, which is thiocyanate ion. Right? This is SCN minus is thiocyanate ion. So this is the test of thiocyanate ion. This tells us that we have nitrogen and sulfur. Both of these are present in the organic compound. Right? So that was all about inorganic chemistry. Let us move to physical chemistry. The question is, calculate the molarity of a solution having density 1.5 gram per ml Given percentage weight by weight of solid is 36%. Excellent. So we are given with this, we'll take an assumption. Let us say we have 100 gram of solution. And in 100 gram of solution, it is given to us that we have 36 grams of solute and the rest would be 64 grams of solvent. And the next thing is that the density of the solution is 1.5 gram per ml. We know density is mass by volume. So mass would be density into volume, although I am interested in volume, so volume would be mass by density. Mass is 100 divided by 1.5. This volume is in ml, and if we talk about molarity, molarity is moles of solute divided by volume of solution in liters. So moles of solute is the mass of solute, which is 36, divided by the molecular mass of solute, which is again 36, divided by the volume, it is 100 divided by 1.5, but this value should be in liters. So what I can do here is I can say this is 100 by 1.5 divided by 1000, which is as good as 1 by 15. So instead of this, I'll write it as 1 by 15. So this goes away. I can directly see the molarity is 15 molar, or I can say 15 moles per liter. Very simple question. So we are observing that a question from concentration terms is coming every time. And in the last two shifts also we got a question from concentration terms. So it is highly probable that in the next shift we'll get a question from concentration terms again. Okay. Next is a pretty simple question from thermodynamics. If we talk about the delta G, we know delta G less than 0 means a spontaneous process, right? And delta G is equal to 0 means a reversible process or a process which is at equilibrium. So this is correct. If this is correct, this is incorrect. And I think this is also incorrect, right? Delta G greater than 0 should be non-spontaneous. So C and D are incorrect. Maybe there is a typo. I think the question would have been something like this, right? If the question was like this only. And this is also correct in that case. The incorrect option would be delta G greater than 0 for a spontaneous process is incorrect, right? Pretty simple question. Slightly tricky question. They say that K net is basically K1 into K2 by K3, and we are given with activation energies. They are asking the value of EA net. So if we talk about K is basically Arrhenius constant, which is A e to the power. K is rate constant, A is Arrhenius constant. So if we talk about the K net value, K net is K1 into K2 by K3. K1 is basically A e to the power minus EA1 by RT. If I eliminate these useless variables, I can see this would be EA3 by RT. And now let us eliminate these Arrhenius constant. In that case, we can see we'll have E, and considering the RT to be the same, it would be minus EA1 plus EA2, and if the denominator part goes up, it would be positive sign, or the sign would get reversed. Since I have taken minus common outside, this will be the EA net value. So I can directly say EA net would be E1 plus EA2, which is 50 plus 40 minus 60. 90 minus 60 is 30 kilojoules per mole. That is our answer. Right? Not a difficult question. Next is a question of balancing. They are asking us to balance this reaction, and the values of A, B, C, D were given in the options. This is a disproportionation reaction. Whenever we balance a disproportionation reaction, what do? we write the species which is getting disproportionated 2 times like this. Okay, so we have ClO minus and Cl minus. The oxidation state is 0, the oxidation state is 0, the oxidation state of chlorine is +1, the oxidation state of chlorine is -1. So if we see the change, this change is of 1, this change is of 1 again. So I can directly write, I can cross multiply the changes, right? So 1:1, and if I balance this, I will get 2 ClO minus, and if I balance it through this case, it will be 2 Cl minus again. So very simple balancing. 2 Cl2 is giving 2 ClO minus and 2 Cl minus. If I want to eliminate all 2's, I can eliminate, right? I'll get something like this. And to balance the oxygen, what I am doing, I am adding 1 H2. It is always easier to balance the reaction in acidic medium, so first I am balancing it in acidic medium. I'll get something like this. Everything is balanced. Now to convert this into basic medium, I'll add 2H minus on both the sides. So 2H minus on both the sides. This 2H plus and 2H minus will produce 2 water and 2 water. There is 1 water on the left, 2 waters on the right, so we will be left with 1 water on the right. So the reaction would be Cl2 plus 2OH minus is Cl minus plus ClO minus plus H2. So if you see here, I think A, B, C, D were the simplest ratio values. Okay, so basically you can see 1, 2, 1, 1. Right, so it would be 1, 2, 1, 1. That is our answer. Next is the correct set of 4 quantum numbers of valence electrons of rubidium. So the questions, this is a question from quantum mechanical model, and it is one of the frequently asked topic as well. So let us be well prepared in quantum mechanical model as well as quantum numbers. If we talk about rubidium, rubidium is 37. It just comes after the noble gas, which is krypton 36. If you want to write the complete electronic configuration, you can write 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, then 3d10. So you will see this is 10, this is 10, 20, 30, then we have 4p6. After 4p we will have electron in 5s, so 37 is this. So we are being asked the quantum numbers of this electron. So as you can see, the shell is fifth, so n is 5. It is present in S subshell, so L is 0. If L is 0, ML has to be 0. MS could be plus half or minus half. Right? So we could have easily matched one option. Next would be a surprise for some of the students. They would say that partial pressure is from states of matter and it is out of syllabus. That is not the case. Partial pressure is used everywhere. It is used in liquid solution. It is used in, I can say, mole concept as well, when we talk about mole fraction. So partial pressure is mole fraction into total pressure. This each student should know. So if we talk about partial pressure of H2, that is mole fraction of H2 into total pressure. And if we talk about partial pressure of O2, that is mole fraction of O2 into total pressure. They are asking the ratio of this. So when I take a ratio, PT goes away. This is moles of H2 by moles of H2 plus moles of O2 divided by moles of O2 divided by moles of H2 plus moles of O2. The total moles are the same, so the ratio is very simple, moles of H2 by moles of O2. Moles of H2 would be 1 by the molecular mass, which is 2. For O2 it would be 1 by 32. See how simple question this is. 16:1 is our answer. Right? So that was all about physical chemistry. Now let us move to organic chemistry. So the first question is, hydrolysis of protein gives which type of amino acids? So all proteins are composed of alpha amino acids only. All amino acids which we have in syllabus are alpha amino acids. What are alpha amino acids? Basically, if we talk about a carbon, the carbon is connected to a COH group, and an NH2 group, we can have H or R, something like this. The COH connected to a particular carbon is called as an alpha carbon, and on the alpha carbon only we have amino group. So that is why we call alpha amino acids. Proteins are composed of alpha amino acids only. Right? Interaction between pi bonds and lone pair of electrons on adjacent atom is called as, oh my god. So I think no student would have done this question incorrectly. And I can do like this, or I can have a lone pair like this. I hope you know this is a conjugation, and this is a type of resonance, right? Double, single, minus. There are other types of resonance as well. Double, single, double, double, single, plus, double, single, plus, double, single, minus, double, single, dot, and the final one is A and B. If B or A has a vacant orbital and the neighboring atom has a lone pair. So these are the 5 types of conjugation, right? We can say these are 5 types of conjugation. So this is resonance. Other options are anyways useless only. Energy difference between natural structure and its most stable resonating structure having least energy is called as. So basically what they are saying is they are asking the definition of resonance energy. Right? Resonance energy is basically, if I see that I have 2 structure, one structure is resonance hybrid and the other structure is a most stable resonating structure. The difference between these two is called as resonance energy. Right? So we are seeing lot of questions from GOC this year. In every shift I think we are either having 1 or 2 questions on resonance every time. Right? So this is the first question of reaction mechanism. We have benzene, and on the first and second carbon we basically have H plus and H2. So we want to do protonation, and on protonation we'll get an H here and a more stable carbocation at this position, because this is benzylic position, this is resonance stabilized. And since we have water, this will get converted to OH like this. CrO3H plus is basically an oxidizing agent. It is also known by the name of Jones reagent. It is going to oxidize the 2 degree alcohol into ketone. If it was 1 degree, we would have gotten an acid, but now we are getting a ketone. Right? It had to stop at ketone because you know the next reagent, which is Wolff-Kishner reduction. This reaction is also very common. Right? It converts the double bond O into 2 H groups. I hope you know the name of this, Wolff-Kishner reduction. The conversion of C double bond O to CH2. Right, that is happening in this step. So basically we are getting ethyl benzene. Right, again a very easy question. So this question is directly from hydrocarbons. If you talk about chlorination, we are doing it in 2 ways. One is photohalogenation, or you can say with the help of HNu or UV light, or we could have taken a peroxide as well, or we could have taken NBS, NCS. So basically in the presence of light, a free radical is formed, and free radical is stable at allylic position. So we'll get a free radical here, and after that chlorination will take place in this fashion. Right? This will be our answer. Next we have Cl2 and CCl4. So here we will be having a non-classical carbocation. I hope you know this. We'll get a chloronium ion with a Cl minus, and then Cl minus will attack here. We will get an anti-product. The 2 chlorines would be anti to each other. This is a vicinal dichloride. right? In the first case we are just attaching one chlorine, in the second case we are attaching two chlorines. Simple question from hydrocarbons. So every year they ask a question of hydrolysis or the reaction of ether with HBr or HI. Every time they do this. What do we need to do? First of all, we can see HBr is in excess, so it can attach on two positions, right? One position is first H plus will be attached. Where it would be attached, I can say on oxygen in this fashion. Then Br minus will come and it will attack here, and we will get phenol like this. You know this phenol bond cannot be broken because oxygen is having a partial double bond character with the immediate next carbon. So we'll get this, and apart from this we will also get CH3CH2Br. If you talk about the other group, we have something like this. We can like the last to last question, what we can do is we can take this double bond and attack on H plus, so we'll get a positive charge here, and then bromine will get attached here, right? So we'll get the answer like this. This will be our final answer. We'll have one OH, and then at the bottom carbon we have one carbon connected to Br and CH3 as well. That is our answer. Positive Fehling solution test is given by. So I hope you know Fehling solution test is given by aldehydes, and then specifically if we talk about, it is given by aliphatic aldehydes. Only aliphatic aldehydes give this test. Aromatic aldehydes do not give this test. Okay, so this is an aliphatic aldehyde, this is aromatic, aliphatic, aromatic. So the correct answer would be 3. Right, very easy question again. So that is all for this paper as well. You can see the question paper was again very simple. Again I would like to highlight some important chapters. DNF block, coordination compounds. I think I did this in the last discussion lecture as well. Coordination compounds, as I can see, GOC is also being asked lot of times, and biomolecules. I would say these are the chapters from which 1 to 2 question is going to come definitely, and biomolecules or POC. So let us be very strong in these chapters, right? So thank you. We'll end now.